Hello, I hope you are having a great night. My name is Jonathan. I'm here representing my team, Team 5, for the stage of selective topics of physics. And in this video, we will be showing you in what consists our integrative learning product, which is an experiment using the Pascal's principle. The reason why we selected this topic is because it's not a hard topic to understand, It's very short, so we thought it would be nice if this didn't take that much time to be made. But I'm telling you now, this took a lot more time than we originally thought. But anyways, I hope you enjoy the process of the making of these experiments. We will be showing you the 2 tries we did. The first one being a complete failure and the second one being our incredible success. And don't worry about my partners. They will be appearing in a few more minutes to explain something very important to you. For our first try, we needed some specific materials which consist of cardboard, cutter or a little knife, 2 color sheets, a glue stick, 1 meter of plastic hose, a metric ruler, scotch tape, silicone, a silicone gun, 4 syringe, water, and scissors. First of all, we will use the ruler and a pen to draw a square of 17 centimeters by 11 centimeters. We will cut them with the scissors and then glue them with the silicone gun. It has to be one above the other. After that, we will cover them with one of the color sheets. Then we will use again the pen and the ruler to draw 8 squares of 13.5 by 2 centimeters. And then we will cut them with the scissors. Now we will take 4 of the 8 and we will glue them with the silicone gun, one above the other. And then we will do the same with the other 4 squares. So now we have 2 cardboard bars that we will serve as columns. But first we have to place them on the cardboard base, the big one, and with the pen draw their areas, and with the knife we will cut through it to have 2 empty spaces. In those empty spaces we will glue the carton colors with the silicone gun, and we will make sure that the faces of the bars are looking at each other. Now we will take 2 of the syringes and take off their needles. Now we will glue them one on each column, and we will make sure that the part that we now took off the needles is at the top. And to be sure that the syringes are actually attached to the columns, you can use a little of scotch tape. Then we will use the pen and the ruler to draw another square on the cardboard of 10 by 6 centimeters. This one will be served as the base of the elevator, the one which will be lifted. We will cut it with the scissors and then cover it with the other color sheet. And now with the silicone gun we will glue it to that thing that we move on the syringe, so it can be lifted when the experiment is done. Now we take the meter of plastic hose and we will cut 2 pieces and we will place them on the top of the columns where the syringe are. Now we take the other 2 syringe and we will glue them so they can be together. We will place the other extreme of the 2 pieces of plastic hose on each syringe, and then we will take off that thing that we move on the syringes so we can fill them with water. After that, we just close them again and we should finally be able to use or experiment in a good way. Unfortunately, that was not the case. Let me tell you that we suffered a lot of water leaks. The silicone didn't work that well on that base that it was supposed to be lifted. The cardboard wasn't a good material after all. The circuits were out of proportion on each other, so they were being filled at different times, which caused again that the base that was supposed to be lifted fell off. And as I already said, it was a complete failure. It didn't work. If we are honest, at first we thought on delivering this failure to you, but after some advices and help, we knew that we had to do something good. And that good thing we will be shown to you in a few minutes, but first we have to explain something to you. There is an important question that needs to be answered right now, and that is, what is Pascal's principle? So for that, I'll let you with my partners so they can explain it to you.
Hi, my name is Naomi and I will talk about Pascal principle states that pressure changes at any point of an enclosed and resting fluid are transmitted to all points of the fluid and act in all directions. It can be applied to many devices that are used in daily life and the industry. A good example is the hydraulic elevator that this experiment is about. But to explain this principle in a better way, we will use the hydraulic pressure as guide.
Suppose we have a hydraulic press with its 2 cylinders and pistons. For this device to produce the desired effect, that is to multiply the force, the cylinders and their pistons must be of different diameters but are connected as systems of fluid-filled communicating vessels. If a force 1 is exerted on the piston of a cylinder 1, it causes an increase in pressure in the liquid. According to the principle, the liquid transmits the pressures without change, so that in cylinder 2 there will be an equal pressure that will act on piston 2.
Hi, my name is Cecilia Lopez Ovalle. Okay, since the pressures change are transmitted equally to all points of the liquid, we can match the pressures of the 2 pistons, as you can see in the formulas that are being shown to you right now. Okay, if we analyze that formula known as the hydraulic press equation, we know that if we have pressure for 1 on the lower piston, the force generated on the lower piston force 2 should be greater of that equilibrium is folded as the area of the lower piston is greater.